get ready for it. Here's where we start using logarithms to do some really useful things algebraically, and helps us simplify exponential equations and stuff like that. So first of all, you might have noticed there's a log button on your calculator. And you might think, oh, is this just solve all logs for me? And the answer is not exactly. It's a very specific type of logarithm. Specifically, the one on your calculator refers to a logarithm of base 10. So when you see it on your calculator, log x, really what that's saying is log base 10 of x, unless it says something else, but usually it will say that. So basically, this right here, let's think about what x is going to be here. What's the answer to this equation? 10 to the power of x equals 100. 10 to the power of what gives us 100? We should know the answer is 2, but the question asks us to find this in log form. So remember, log, base is the thing that is the base of the exponential, which goes down here like this. 100 is the thing that goes inside the log, and this equals x. Remember, the exponent is the answer to a logarithm, right? The exponent that this is raised to the power of is the answer to the logarithm. So the thing is, if you do log 100 on your calculator, what's it going to give you? If I just do log 100 on my calculator, and you should try it, it's going to give you 2. And does that make sense? Remember, we said the answer to this equation is obviously 2. 10 to the power of 2 gives us 100. So when you type in log 100 on your calculator, really what it's doing, it's finding the power of 10 that can give us the value that you put in. So if we go over to this next example, what's the answer? 10 to the x equals 200. What's the answer to that? X to the power of what? Well, if you think about it, x to the power of 2 is 100. X to the power of 3 is 1,000, right? So we know the answer's got to be between 2 and 3, and it's probably going to be closer to 2, right? But it's going to be some weird decimal answer. You can use trial and error, blah, 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 to do all this kind of stuff. But instead, let's write this out in log form. So essentially in log form, this is going to be log base 10 of 200 is going to give us x. And remember, on your calculator, it automatically assumes base 10 when you press the log button. So if I just type in log 200 on my calculator, what does it give you? I'm going to try it right now. Log 200. Log 200 gives me 2.30102999, blah, blah, blah. So this gives me approximately 2.30. So remember, what it did is it actually found the exponent of 10 that will give us 200, and the answer is about 2.3. So in short, that's what the log button on your calculator does. If I was to rewrite this back out as an exponential, remember there's like a little hidden 10 here when there's no number given. So it's like saying 10 to the power of 2.3 is approximately equal to 200, right? So the log button on a calculator is useful, right, for being able to solve equations like this, where we don't have to use trial and error anymore. We can find an exact, or in this case, an approximate answer to that very quickly. Lastly, we have this one, 10 to the power of x equals 16. So again, I'm going to write this out in log form. Log base 10 of 16 is going to give me x. And on my calculator, all I need to plug in is log 16. Predict what it's going to give you before you actually do that on your calculator. So 10 to the power of 1 should give us 10, right? 10 to the power of 2 should give us 100. So it should be between 1 and 2, right? That's what the x should be. And if you do it, x comes out to be 1.204. So approximately 1.20, which makes sense. It's closer to 1 than it is 2 because 16 is not that much bigger than 10. So there we go. So we basically solved this exponential equation using some logs. So 10 is a common log that your calculator will use, or a common base that your calculator will use for logs. There is one other one. There's a very common base called e. And E actually stands, if I zoom in here, E actually stands for Euler. Very famous math guy. Google him. Pretty interesting stuff. Pronounced Euler. But the E stands for Euler. It's his constant. It's called Euler's constant. And it's basically comes out to the number 2.718 blah, 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 blah. It's an irrational number. So like pi, it never repeats and never ends. And it's a very useful number in calculus and a lot of financial applications and stuff like that, actually. So it's a pretty important number. So important that your calculator actually has a separate log function for base e. So whenever there's a button, and it should be beside log, and it's ln. And ln, not just my initials, it's the lawn button. We pronounce it lawn, like as in lawn, like you mow the lawn. So it's ln, and it's a logarithm with a base e. So if we go down here, and we have an equation, e to the x is equal to 10. Remember, e is just a number, 2.7, blah, 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 blah. But if we wanted to solve this equation, we could do log base e of 10 equals x. So remember, e is 2 point something, something, something. So we would expect e to maybe be, I don't know, in the range of 3-ish, right? 2 times 2 times 2 is 8. And it's a little bit bigger than 2, so we'd expect e to be something like that, or sorry, x to be something like that. But our calculator, actually, whenever we do base e, we can use the ln button. So ln of 10, and if we do ln 10, try that button in your calculator, it should give you 2.30 blah, 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 blah. So approximately equal to 2.30. So that just solves this equation whenever the base of the exponential is e. So these two are pretty simple. You should be able to solve these without using your calculator at all. But if you can't, let's break them down into log form. So e to the power of x equals e. Again, you should be able to solve this just by inspection. But just to show you what the log does, it would be log base e of e is going to give us x, because x is the exponent, right? So in your calculator, you can actually replace the log base e with just ln of e is equal to x. And if you do that, the e button should be the second function for ln, or you can find it somewhere else. It's a lowercase e, it should be somewhere. If I do this in my calculator, it should give me 1, right? Because if you look at the original equation, obviously e to the power of 1 is going to give me e, right? But just to show you on your calculator, it should give you that. And next, this one here, what to the power of x, or sorry, what power of x is going to give us 1 when we raise e to the power of it? Again, e is just a number, and this should be obvious based on what we did in the last lesson. But just in case, I'm going to write it out in log form. So log base e of 1 equals x. And if we do, and again, log base e, we can do ln of 1 equals what? And if you do it in your calculator, you should get 0, right? Because anything to the power of 0 is going to give us 1. So that's actually a thing. On your calculator, if you do log to the power of 1, right, it doesn't matter what the base is, log to the power of 1, it's going to give you 0. Ln to the power of 1, it's also going to give us 0. Because anything to the power of 0 is going to give us 1, right? So in this case, x just equals 0. Okay, so that was our summary of common bases that your calculator can do. Base 10 and base e. We're actually going to see in this course, we're going to see base 10 much more than we see base e. Base e will come back in calculus a lot. So the question is, what about if the base isn't 10 or e? How can you do that on your calculator? Well, I'm not going to lie, some calculators are able to do any base. So you might have a function that lets you put in any base for the logarithm, which you're welcome to use. But if you have a more standard calculator, we can do what's called a change of base. And a change of base allows us to plug anything in, any base into a logarithm and simplify it into any base we want. So the formula just looks like this. The log base b of m is just going to be log m over log b. So what this means, it looks a little bit confusing here, but all we have to do is do what's inside the log, do that on top, and do the base on the bottom. So if we do an example question here, I'll leave that in the top corner so you can still see it. Log base 3 of 67. Most calculators don't have a log base 3 button, they just have a log base 10 button. So what we can do is we can write this out as log of the top, so 67, over log of the bottom, so log of 3, right? Or sorry, log of the base. And this is an equivalent expression to this. I'm not going to go through the proof of why it works here. We'll save that for another day, but suffice to say that it does work. And in fact, when you do this on your calculator, it's assuming base 10, right? It's assuming a little base 10 here and a little base 10 here. But the bases can be anything you want, as long as they match for the numerator and the denominator. So I could do log base e of 67 over log base e of 3. It doesn't matter as long as the bases are the same. We usually use 10 because that's what calculators are able to do. So if I do this in my calculator right now, log 67 divided by log 3, it's going to give me the answer. So it's basically going to give me the number that 3 needs to be raised to the power of to give me 67. So the answer to that, if we do it on our calculator, is 3.83. There we go. So 3 to the power of 3.83 is going to give me 67. Again, this is called a change of base. Try the next question yourself, and then you can unpause the video and see the answer. So here, very quickly, we can use change of base. If your calculator doesn't have a function to change the base, we can just do log of 564 over log 7. And again, these are going to be both base 10s when you do them in your calculator. Log 564 divided by log 7 gives us 3.26 approximately. So 7 to the power of 3.26 is going to give us 564. So just to take a step back and look at what we're able to do now. This, remember, log base 3 of 67 is like saying 3 to the power of something gives us 67. And log base 7 of 564 is like saying 7 to the power of something gives us 564. So we now have the power to basically find out what that exponent is, in either case, just by doing